The Maritime RobotX Challenge is like the stock car race of robotics competitions. Every team starts with the same basic WAM-V platform.
Then it's up to them to decide how to equip it with the hardware and software it needs to fulfill the mission.
The level of innovation that these teams are bringing in their hardware and software solutions, and just the level of creativity, is truly inspiring as we look to the future generation of engineers.
Compared to the relative shelter of Singapore's Marina Bay, the Pacific winds and waters make independent maneuvering of the WAM-Vs not quite as easy as you might think.
The choice of propulsion and dynamic modeling of the boat can make a big difference in navigation and station keeping.
The wind here in Hawaii is much stronger than what we had back in Singapore, so because of that our control system needs to compensate much more.
So our WAM-V has 6 motors tilted at 30 degrees to give us holonomic drive. The downside of this configuration is we have less forward thrust, and we're finding that we're having trouble moving forward against the current.
If we come back to Hawaii 2018, I think we have to install more thruster to control the vehicle precisely in this kind of harsh environment.
Modern sensors range drastically in capability and expense. Teams need to balance the need for quality perceptual data with the ability to process it quickly, reliably, and cheaply.
We're using 2 Hokio LiDAR sensors, we're using a Stereolab Z camera, and we're using 3 IP network cameras, so for port, starboard, and stern vision.
We don't use SLAM. We have a really great GPS INS system. The creator is actually here and he's donated it, so it gets like centimeter accuracy. SLAM could be more difficult in the ocean because there's not a lot of feature points and stuff.
A remarkable software trend since the first RobotX competition has been the accessibility and performance of machine learning approaches to tasks such as computer vision.
We use machine learning pretty extensively in our robot. Our primary sensor is computer vision, so in order to do the computer vision on our boat, we run basically all of that through a deep neural network, which is basically like a small brain that helps us interpret our environment.
Teams do their best to predict and prepare for the various ocean conditions their boat may encounter, both through in-water testing and the use of simulation.
The simulator has a lot of input parameters such as wind, the buoyancy of the boat and undercurrent as well. So the first time we ran the navigation challenge, it was only running the simulator. So the simulator was very, very useful for that. I ran first go.
We used Gazebo simulator, which is integrated with Ubuntu and ROS. Having a full physics simulator is really a massive help for us.
No single hardware or software approach is a guarantee of success in a complex environment like RobotX.
One of the advantages of the competition is that teams get to learn and be inspired from one another's innovative solutions.
To find out more about each team's design decisions, visit robotx.org.